Question 22, JAMB 2023 past question, physics. Addition of trivalent impurity to a semiconductor dash. A increases the number of holes, B decreases the number of holes, C increases the number of free electrons, D decreases the number of free electrons. Yeah, the correct answer to this question first is A, but let's explain why is it so. First, what do we call semiconductor? Now, in basic electronics, semiconductors play a very great role. They have wide application. They are even the major components of that they use in electronics. So especially in computers and communication industries. Now, what are semiconductors? Semiconductors are those elements whose property is in between good conductor and poor conductor. So they are neither good conductor nor poor conductor. So it's just like metalloids in chemistry. Examples are silicon and germanium. Now, in every semiconductor, we always have two charge carriers. Let's draw just a simple diagram of a semiconductor. Now, we always have two charge carrier. We always have an electron, which is negatively charged, and we always have a hole, which is positively charged. Electron, negative, hole, positive, electron, negative, hole, positive. This is electron, while this is hole. Now, generally, semiconductor can be classified into two. We have pure semiconductor and impure semiconductor. In pure semiconductor, the number of holes is always equal to the number of electrons. That means it will be neutral. Now, there is something we call doping. Doping. D-O-P-I-N-G. Now, that's if we want to turn the semiconductor to a positive one, we carry out doping. If we want to turn it to negative semiconductor, we also do doping. Now, if we turn it to positive semiconductor, that's called P-type semiconductor. Then, if we turn it to negative, we call it N-type semiconductor. Now, by doing this, that means we have turned it to impure semiconductor. It is impure semiconductor that is always like this. Now, the P-type semiconductor has more holes than the electrons, while N-type semiconductor, which is negative, has more electrons than the holes. Now, how do we achieve P-type semiconductor and how do we achieve N-type semiconductor? Now, to achieve P-type semiconductor, we are going to add a trivalent element. A trivalent element. What do you mean by trivalent element? An element that its valency is 3. That is, it has 3 electrons in its outermost shell. For instance, boron is a good example, and indium. Now, let's take, for instance, we add boron to germanium or silicon. Boron is trivalent. If we add it to silicon, now this boron is an impurity that we are adding to the pure semiconductor. Indium is also an impurity that we can add to the pure semiconductor. Now, the impurity can be divided into two. We have the donor impurity and the acceptor impurity. Donor impurity are the one that always donate electrons to the semiconductor, while acceptor are the one that always accept electrons from the semiconductor. Now, this one, boron, it has 3 electrons in its outermost shell. It is an acceptor semiconductor. It will accept electron from the pure semiconductor. So that means the pure semiconductor is losing electron. As it is losing electron, that means we will have more holes than the electrons. So that means it will increase the number of holes. So doping a semiconductor with trivalent impurity will increase the number of holes. But if we use donor impurity, donor that always donates electrons. So the donor impurity, as they are always pentavalent. Pentavalent, that is, they always have five electrons in their outermost shell. That is, their valency is 5. A good example of such is arsenic and antimony. Now, what arsenic and antimony do if they combine with either silicon and germanium is they will, first of all, 4 of the 5 electrons, they form covalent bond with the germanium. There will now be remaining 1 free mobile electron. This free mobile electron is the one responsible for the negative charge that is on it. So that means if you add pentavalent element to a semiconductor, it will decrease the number of holes and increase the number of electrons. So that is how it goes. But if we add trivalent, it will increase the number of holes. Thank you for viewing this. God bless you.